Okay, so we're talking about inverses. This is day 2 on inverses. So if you have 1, 5, like 1 comma 5, and you change it to 5 comma 1, you just flip it around. That's what an inverse does. 2, 6 turns into 6, 2. 3, 7, 7, 3, etc. And the range and the domain here turn into the opposite of themselves. The domain becomes the range, and the range becomes the domain. All right, so when you have a picture, I really kind of like seeing what they look like. If you have a picture on the test, and they give you a picture of something like that, for instance, I've been using this example for a long time because it's a great example of an inverse. That is the graph of y equals e to the x. That's called the exponential function. You had to memorize that one on your list of 12 functions. The other one, that's the inverse of it, is like this. If you go across this line, straight across from that point to that point, for instance, or this point to this point, straight across the line, this point to, say, that point, that point to, say, that point, and then go some of these. Eventually, you'll get this graph, which is the graph of log. Natural log. All right, I know you don't know those functions terribly well yet, but you've seen them a few times. I've shown them to you. They are inverses of each other because they are exactly flipped across that line, y equals x. Okay? So if this one has the point, let's say, 6 comma 8, then this one would have to have the point what on it? 8 comma 6. So the question could be as simple, like this would be our 2-level question. If a function has the point 2 comma 7 on it, what would its inverse have on it? 7 comma 2. It's just reverse. Okay, so inverses can be that simple. Or they could say the domain of this one, think about this for a second, the domain is all the things that work from negative infinity all the way to, how far would it go that way? Positive infinity. So this guy's domain is negative infinity to positive infinity. What could you say about this guy's domain then? The same. Now I know that that doesn't look like it has that domain, but it does, meaning that those are numbers that would be okay in the inverse. And you can't just look at the picture to try to get your domain and range. You take your domain and range of the original, and then you say, flip them, and that's your domain and range of the inverse. It's just like before when we were doing f of g of x, and we were figuring out, let's say that you got all done with your f of g of x thing, and it came out to like 1 over x plus 5. And then people wanted to just look at this and say, what's the domain from this? You can't do domains that way. This would look like you can just have negative 5 is the only thing that wouldn't work. But the reality is, it depends on what the parent domains were. Remember, you have to do the one and the other, and then we have to do this whole big formula thing, and when it's all said and done, you're like lining up stuff like this and seeing where do they overlap. That's what you got to do to get the domain. You can't just look at the answer and try to say, what's the domain of that? Doesn't work. By the way, what was the big formula for if I want to do f of g of x? Just a 2-second reminder of that formula you have to know. It's d of the inside one, g, intersect with g of x in d of f. If you don't have that memorized, you better memorize it. You got to know. You got till Thursday. Thursday is the test. Okay. Not only just you have to memorize it, you have to know how to do it. We'll review that stuff tomorrow and the next day, and then the test is Thursday. I know it's been a kind of crazy weekend. I'm sure a lot of you guys had parties and stuff to go to because it was Halloween weekend. Anybody actually got a chance to go to a party, hang out with some friends, watch scary movies, that kind of stuff? Cool. So what's they're just too shy to raise their hands. Probably more than that. So what's a good scary movie to watch nowadays?
Paranormal Activity. It's not even scary. It's not even real.
Paranormal Activity was suggested. How about... I've heard there's one called Insidious that's supposed to be decent. Oh, really?
It turns into like a biblical story.
Oh, okay. Yes. Who? What? Megan is missing. Good scary story. Okay. Is it R or is it people chop off their legs with hand saws or anything? I'm going to pause. Okay, we paused because we had somebody come in interrupted us for a second, but I'm back. Let's talk about functions and their inverses again. Is the inverse a function? Well, remember, if you graph something and you look at it, you can tell if it's a function by checking the vertical line test. Would this pass the vertical line test? No, the big Z for Zorro would not. It would be hit twice or three times, depending on where you were. Anyway, and if you reverse this and make it the horizontal line test, that doesn't tell you if the thing is a function or not. That tells you if its inverse would be a function. Would the Z's inverse be a function? Yes, it would, because it passes the vertical line test. So the horizontal line test right here, you need to know what that is. You need to know how to use that. You use that to test and see if something's inverse is a function. Some of you aren't writing stuff down. It makes me nervous for you. Make sure your pencil is in your hand. All right, moving on. How is the inverse formed from a rule? Basically, there's a three-step. Write y as f of x. Then exchange x and y in the equation, and then solve it for y. All right? So I'm going to show you that one right now. Here's a function. Oh, sorry, f of x is how we're supposed to start. So there's a function. Write it down, and do the three-step process, and turn it into its inverse. First step, y equals. Second step, flip them. Third step, get y alone. Sounds like a part of a horror film. You notice how they're always alone when they get separated from the group? Yes, they always open the creepy door. Y equals x minus 7 over 3. Raise your hand if you had that one right. Okay, good. That's the easy kind. Now let me show you a sneaky good way to make sure you did it right. It's really easy to test these and see if you did it right. Here's how. You pick any point, like if you find a point like 2 comma 5 that works in here, then its inverse 5 comma 2 would work in the inverse. So I got to find a point that works, any point. So you pick anything that works, like if I put in 1 for x, that would be 3 times 1 is 3 plus 7 is 10. 1 comma 10 is my point then. It could have been 2 comma 6, 13, that would have worked too, but anyway, I'm checking to see if I did it right. So if 1 comma 10 works in the original, 10 comma 1 should work in here. Check it in your head quick. Stick in the 10. Would it really equal y is 1? Yes, it would. 10 minus 7 is 3. 3 over 3 is 1. That's a way to check and see if you did your function right. Would you need one of those? Don't have to. Does your grade depend on it? Of course. There's only 8 questions. You get one wrong, no big deal. Get another one wrong, you dropped a whole grade. Get another one wrong, you dropped another whole grade, right? So these are whole grades we're talking about, which is like A's to B's to C's, because there's only 8 questions on the test. So yeah, you want to check yourself before you wreck yourself. Yes. If you end with a fraction, do you need to simplify it? Well, the question really is, I want to make sure that this is right. I'm not even going to test you on whether or not you checked it. So you did it any way you want to. I personally would just do it in my head and say, 10 minus 7 is 3. 3 divided by 3 is 1. It worked. I know it worked. Yay. I'm probably right. Okay. All right. Here's one more like that where we're going to change this into its... And this is tougher. Try this one. This will separate the people that are good at algebra from the people who are just posers. You keep working on your paper. I'm going to just start it. All right. Now, my advice on this kind was to get rid of the fraction, clear the fraction. I hear that a lot from the calc teachers, so it must be one of those things you'll use a lot next year too. Clear the fractions. All right, so I'm going to multiply this by x plus 7. Multiply it by x plus 7. Sorry, y plus 7. That way, it'll clear this fraction right there. Y plus 7 on both sides, sorry. X times y is xy. X times 7 is 7x. Now, I do multiply it all the way out. That's the other thing you need to make sure. And now you got y's on both sides. You have to fix that. When in any equation you're trying to get the y alone, you got to get it all of them onto one side. So I take away the y from this side and put it over to that side. At the same time, I'm going to put this x over to that side because I don't need them over there. I just want the y's alone. So I'm going to have xy minus y equals negative 7x. That was 2 steps at once. I got rid of the y, moved it over to the other side, moved the x over to the other side. Okay, next step. This is where the leap of, it's not genius, but once you've been showed this, I have shown it to you, I'm sure you remember it. Y comes out x minus 1. You remember that part? There's a y on both of them. You got to factor it out to the front. Okay, next step. Divide by x minus 1. Cancels. Your paper isn't going to have lots of room, so that would have been good enough right there. But I have unlimited room because I can keep sitting, extend page if I want to. There it is. Raise your hand if you had that before I did. All right, that's like 8 or 9, 10 of you. All right, so that's about 1/3 of you. That's the kind of problem you have to do right to get an A. Let's say you think you did it right, but you're not sure. Well, you can test a point. This is more complicated because this one isn't very nice because it's got a fraction in it. But if I wanted to put in a 1, if I put in x as 1, I'd have 1 over 8. So 1 comma 1/8. If I'm going to check that down in the inverse, it's going to be 1/8 comma 1. If you put in a 1/8 here and here and a 1 here, it actually works. It'll be negative 7/8. I need to extend my page again. 1 equals negative 7/8 over 1/8 minus 1 is negative 7/8. Look at that. And that equals 1, doesn't it? So it worked. That's how you can check yourself. You do not have to do that. I'm just trying to give you a tip that it's smart to check because a lot of times kids will make a little dumb algebra mistake in there. What if you check it and it doesn't work? Then you screwed up your inverse somewhere. Go back, look over your work, find your mistake. It's really, I mean, it'd be really helpful, wouldn't it, if the teacher would walk by and say, hey, by the way, you did number 3 wrong. Well, that would be really nice, wouldn't it? You'd take time, figure out where you screwed up, you'd probably find it. You can do that for yourself. By the way, I did number 3 wrong. Oh, all right. Moving on. This is, how is the inverse formed from a graph? That's the whole reflection over the line y equals x. Okay, I guess I already talked about that before. Then there's one last thing I have to teach you, and that is if I'm going to prove that 2 things are really inverses. Okay, you know how when I told you that big formula, I said put a star by that in your notes because that's one of the big things you better look back over right before the test, memorize that formula again? This is another one of those moments. Put a star on your paper next to this thing. To prove that a thing to prove g of x is the inverse of f of x, here's what you have to do. If you're given 2 things, f of x and g of x, and they're supposed to be inverses, but you want to prove that they really are, this is the little proof. You got to prove that f of g of x is exactly equal to g of f of x. If that's true, they will be inverses. And one more thing, once you've proved that they're equal to each other, they will simplify down to just be x. You will understand in a second when I show you a proof. But right now, just write that down. G of f of g of x is equal to g of f of x. which is equal to x. All right, so let's do one. We just had one a second ago where f of x was, could you look at your notes for a second and tell me what did I give you? That one where we changed, it was like 3x plus 7 or something like that? Was that it? 3x plus 7? What was the inverse that we got out of that one? X minus 7 over 3. Can anybody verify that? Okay. Well, actually, this is a case where we can prove if that was really right or not, because maybe somebody remembered it wrong. They just told it to me. If I had to prove these are truly inverses, there's a way to prove it. I take f of g of x, draw a line, g of f of x, and I figure both out, and both of them better end up equaling x. All right. Have you got this copied down yet? Okay then, f of g of x. That means take the g and stick it in the f function. This needs to go into this. So I write 3 empty spot plus 7, and then I drop in the other function, x minus 7 over 3. Now the cool part is that things will cancel. Kids tend to lose a point on this because they will just say, oh, it equals x. You can't just jump to the conclusion that it equals x. It's supposed to equal x, but you have to prove it. So you have to show me at least one step of work. Can you see something that would cancel, that I can cancel and then rewrite this problem? Yes? The times 3 and the denominator 3. That's a divide 3. Yes, those will cancel. So I can now write this, x plus 7, no, minus 7, sorry, plus 7. See what I did there? I did one step of work. If you don't have one step of work, you will not get the point. Have to do that. Because I know it's supposed to equal x at the end, but you have to prove it. Now from here, this is just one step. Minus 7 and plus 7 will cancel. Some people ask, doesn't that parentheses matter? No, it really doesn't. You have to understand, and especially in this unit, when you can drop parentheses. Whenever there's nothing that I can do inside, I can't do x minus 7, can I? I don't know what x is. If you can't do that, and there's nothing being multiplied or divided by the x, by the parentheses, sorry, then those parentheses can just be dropped. It's like they're not even there. And then it's just x minus 7 plus 7, which is x. All right, so know when you can drop parentheses. There's nothing to do inside them, and there's nothing being multiplied or divided by them. If it's just add and subtract left, you can just drop those parentheses off. All right, the other side, g of f of x. So in this one, I stick f of x into the g function. So it's going to go this way, this one into that. So that's 3x, no wait, I should start by writing the red function with an empty spot. Empty spot minus 7 over 3. 3x plus 7 goes in there. Can you see one little thing you can cancel? The plus 7 and the minus 7, is I hope what you're saying? Do you think you can cancel off the 3 right now? You cannot. Why? Because it has to be all multiplication on top and bottom for you to cancel those 3. Those 3's cannot be canceled, and that is a very common mistake. This, though, I just got done talking about when I could drop parentheses. I can drop those parentheses, and the plus 7 and the minus 7 will cancel. Then I'll have 3x over 3. Do you see how that's going to simplify to just x? This side was x, that side was x, and they're equal to each other. I have proven that my two functions were inverses. All right, I want you to prove these two functions are inverses. Actually, you know, what I'd like to do is actually do one off of your worksheet. So I'm going to hand out the worksheet so that I can stop doing practice problems and jump into the real thing. That'll have less homework for you for later. All right, so you can put away your notes and do the rest of your work on this thing. Stay with me, though. I'm going to do two problems, one from the front, one from the back. They're always easier when somebody's walking you through it, so take advantage of this. First thing I decided was that this worksheet for a Halloween night was pretty long. So I'm going to ask you to lightly cross off B and C, B and F. B and F on both sides. The reason I'm having you lightly cross it off is that maybe you'll want to do more for practice someday, like before the test. And you want some extra practice problems. Those would be great ones to do. Okay? So cross off bullfrog, B and F on the front and the back. All right, now, that being said, I looked it over, and I think number 1D is the first, like, hard one. Or one of them, anyway. I just didn't want to do the easy one for you, because that's too easy. 1D is what I'm going to start with. Okay? Here we go. It says f of x is square root of 5x plus 1. The directions say find the inverse and state the domain and range. All right, so first I want to find the inverse. Use that three-step process. Y equals square root of 5x plus 1. What's the next step? Change the x and y around. And now what's the last step? Solve for y. How do I get that square root off of there? Square both sides. When I square both sides, I do not get an absolute value. It's when I square root both sides. Okay, x squared equals 5y plus 1. I'm getting close. Y has to get alone. What's next? Subtract 1 from both sides. X squared minus 1. And the last step is divide by 5. I know you don't have much room on your paper, so it'd be fine with me if you stopped right there and said y equals x squared minus 1 over 5. Now, if this was a test, I would take the time to check. I'll give you an example. If I stick in 3 here, 5 times 3 is 15, plus 1 is 16, square root of 16 is 4. 3 comma 4 works. So what better work down here? 4 comma 3. 4 comma 3 better work down here. 4 squared is 16, minus 1 is 15, divided by 5 is 3. And it worked. So that was just a quick test. You do not have to do that on your test. But it's smart. All right. Next thing. The domain and range of the inverse. Don't look at this and try to find its domain and range. You will get them wrong. This is just like that formula thing where you have to use the formula to get the inverse, or sorry, to get the domain of those composition functions. This kind, you have to do it this way. Go back to the original one. What's the domain of the original one, and what's the range of the original one? And then once I figure that out, I'll flip them. The domain will become the range, and the range will become the domain. So what's the domain of the original one? Domain is everything where that will not screw up the function, but I have something that could screw it up. So 5x plus 1 has to stay greater than or equal to 0. So once I solve that, I subtract 1 from both sides and divide by 5. X has to be greater than or equal to negative 1/5. That's the domain of my original. So later, it'll become the range of my inverse. Now the range, I know what this picture looks like. It's a square root, looks like that. And yeah, it's been stretched a little bit, but it still hasn't been moved up or down. So its range is from 0 to infinity. So now, there's my two domain and ranges. So my answer for this inverse here, its domain is whatever the range was, 0 to infinity. Its range is whatever the domain was, x greater than or equal to negative 1/5. I know as you look at that final function, you'd say, well, why do I care if x has to be greater than negative 1/5? That doesn't make any sense looking at this. It won't make any sense looking at that. That's okay. You need to go based on what the parent was, what it started with, and just reverse them. Sort of like you look at you have these two parents, one of which has sickle cell anemia. And their kid now might have sickle cell anemia because it came from the parents. Can you tell just by looking at the kid? Not from the outside, but if I know both mom and dad have sickle cell anemia, for instance, then it's very likely that kid's going to have it. Okay, that's something that's inherited from the parents. This inherits the domain and range from the parents. Whatever the domain was becomes a range. Wherever the range was becomes the domain. All right. So there's 1D. Now let's do one on the other side. Everybody flip it over, please. And let's do the first one there. 2A. It's a pretty normal problem. And it says f of x is 3x minus 2. And g of x, you know what? Wait a minute. That's an easy one. We did one just like that in class. Let's do a different one. Let's do C as in cow. This A is easy. I know you can handle it. Just let me help you with C. C as in cow. X cubed plus 1. And g of x is cube root of x minus 1. Okay. How do I prove that these are inverses of each other? I have to show that f of g of x is equal to g of f of x. And they better both come out to x when I'm done. Okay? So set that up. Write that on your paper. And underneath f of g of x, we stick g of x into the f of x function. This has to go into here, specifically right where the x is. So I'm going to go empty spot cubed plus 1, and then drop in square root of x minus 1. It's cube root, sorry. Cube root of x minus 1. There we go. And now, one step of work. You cannot just simplify it all down and say, it's x, yay, because you know it's supposed to be x. What can I simplify? Do you see that we're cubing a cubed root? Doesn't that make the root fall off? Yes, it does. X minus 1 plus 1. And remember what I said about parentheses, that if there were, a lot of times you can drop them? I can drop these, and I'll have just x. See? It came out to x like it was supposed to. All right, now on the other side, g of f of x. I'm going to put the f of x into the g function. This part needs to go in there now. So I take cube root of empty spot minus 1. In the empty spot, I put x cubed plus 1. And then watch what happens. I cannot drop these two parts. I have to simplify those two parts first. Order of operations. So cube root of x cubed and the plus 1 and the minus 1, they'll just disappear. Because again, we can drop these parentheses in there, and the plus 1 and minus 1 cancel each other out. And now I can say, what's the cube root of x cubed? X. All right, there's one more I want to help you with, and I'm not doing the whole thing, but I'll at least help you with it. E is an elephant. Or since it's Halloween, E is an elephantiasis. Do you know what elephantiasis is? It causes, like, your foot to swell up so big and fat in your whole leg down there that it looks like you have an elephant foot. It's like a big blocky thing down there. And so one of your appendages, it can happen to an arm too, where it'll just swell up to be like 5-6 times normal. It's all just swollen and awful looking. And anyway, elephantiasis equals not good. One other Halloween topic that I'm sure you'll enjoy. Ever heard of fireworms before? They're a real thing. You can Google it if you want to. It happens in countries that don't have very good sanitation. And this little thing gets into you through the water. It's a worm. It starts out so small you can't even tell. It's just, you drink the water and don't even notice you drank one. Gets into you, and then it ends up growing bigger and bigger and bigger. Eventually, it ends up crawling out of you through your knee or your ankle or your wrist or your elbow. It comes out at a joint for some reason. And this worm is can be like 5 inches long. It's really skinny and tiny. And when it starts to come out, people's tendency is to want to just like, oh my gosh, get this out of me, and they pull on it and they break it off. That's very bad because then it is dead inside you and will cause an infection, which is awful. So the natives have learned over the years, after a lot of people probably dying from it, that they have to take a stick and wrap the worm around the stick and slowly pull it out. So it might take a course of a day or two to work this worm out of their ankle or their wrist or whatever, wrapped around a stick. It's called a fireworm. What? It grows inside of you. It gets to be its full size, because you wouldn't have drank it if it was that big. You know what I mean? Oh, I see what you're saying. How does it get its food? Is that kind of what? It's an excellent question. I don't know that. But I'm telling you, Google it tonight. This is not just me telling you a scary story. Because it burns, the sensation as it's coming out, it burns. That's why they call it a fireworm. Yeah, pretty awful. Another good reason to drink clean water. All right. Anyway, I'm helping you with E. F of g of x. The good question. This is 2e. F of g of x, I got to do that, and then I got to do g of f of x. And g goes into the f function, so this needs to go into this in 2 spots. Notice there's 2 x's. That's what makes this a pain in the butt. Empty spot plus 1 over empty spot. I always do that. Notice I've always been doing that. Whenever there's an x, I write a big empty parentheses. So should you. Then you drop in this function. This goes in to both spots. There and there. And I get 1 over x minus 1 plus 1 all over x. 1 over x minus 1. Now, this is the part where some of you will just give up because you don't know how to simplify this. But do you remember back to the beginning of the school year where we talked about fractions in fractions? There was a reason. Now is one of those times. Do you remember how we said you could clear fractions? Multiply by the denominator. That's another way to say that anyway. Multiply by the denominator. So if I multiply by this on the top and the bottom, then I have to multiply it by both parts, by that and by that, and look what happens. When I take this multiplied by this, do you get the whole reason we did that was so that this denominator would cancel this. And now the denominator's gone. And so all I have left is a 1. I'm going to erase this for now because I don't have room for it. I'm going to just show my work over to the right here. Okay. Okay. So that times that makes 1. That times that makes 1 times x minus 1, which is x minus 1. 1 times x minus 1 is x minus 1. All over this one. Times it by this one. And I get x minus 1 over x minus 1, which will cancel. And I have a 1 left. Can you simplify that? Yes, you can. What does divide by 1 mean? You don't really have to do anything for divide by 1, do you? It's like it's not even there. So then we're down to just that top part. And do you see how I was talking about parentheses dropping sometimes? What if you drop those parentheses? See how the plus 1 and the minus 1 disappear? And what do you have left? Just x. Just like we wanted it. I know that was intense. I did the left side. You have to do the right side. That was f of g of x. Now, you do g of f of x. Okay? If you're like, I'm not doing that, it's fine. It's your life. You're not going to get the A either. You have to know how to do that. You don't have to know it tomorrow. Don't have to know the next day, but the day after that. Thursday is when this test is. Okay, so don't shy away from these hard problems. Ask me if you don't know how to do it. So if you came up with a blank sheet of paper and you had g of f of x written on it, and you show me what the functions are, I'd walk you through it if you wanted, but You got to try this, okay? All right. One other thing, I want to give you an alternative. If you thought that was too complicated, you might like this way better. I can find a common denominator of these two guys. To find a common denominator, I would say, all right, this side's denominator is x minus 1. I got to make this have an x minus 1 on the bottom. So I do that by multiplying by x minus 1 over x minus 1. Now it's got a common denominator. And then I can add them together. Now, that doesn't feel much easier to me, but it will work. Then I have a common denominator and I can add the fractions. My way was, again, this is the key thing to get rid of. Multiply it on top and on the bottom. That way, this whole thing is equal to 1. That's why you're allowed to do that. And then you just have to remember to multiply it by both parts. This has to get times by this, which will cancel it. And this has to get times by that also. All right, I'm going to leave that up there just as... That's the hardest thing. If you can handle that, that's the hardest question that you'll often be able to handle. Other than the R4s, which are always just kind of crazy. Yes? If they are really inverses, then they will always come down to x. If they weren't inverses, then it won't come down to x. So on the test, it might say, prove if they are or are not inverses. On this sheet, they all are inverses. Okay. So if you're doing it right, they will all come down to x at the end. It'll simplify, 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 and it'll turn into x. But you can see why we won't just let you say, oh yeah, this turns into x. You got to show some work in between because it's complicated. All right. So, just a reminder again, you're not in an easy class, but you can handle it. Just gotta, if you don't quite get it today, make sure you get it by tomorrow. And if you still don't get it tomorrow, make sure you get some help because the day after that's our last day of review, and then Thursday is the test.